I show you one question from last year's prelim. So I have got a variable x that has got this mean and this variance. Is it normal distribution? They didn't say anything. So this is immediately non-normal. We observe that first. This is one of my conditions. They then have a sample of n of this observation. This n then therefore means sample size. If I want central limit theorem, sample size must be large. But I don't know yet because they never say. They never say how big is n. Such that they mention sample mean is denoted by x bar. This is the usual notation that we know, sample mean. They then say find the least value of n such that this must happen and state any assumption that you need. Let's finish with writing out that this is your third condition first. Your question is looking for average. So the only thing that we lack in order to go for central limit theorem is sample size. I don't know whether this sample size is large or not. They only say it is n. This is also the reason why they say, can you state assumption? We need to assume something before we can start the calculations, which means that we need to assume, just right at the top, I need to assume that this n value is large so that we can have central limit theorem, all the three conditions we have. Okay, so to start the problem, let's write down x bar's distribution by quoting central limit theorem. We will assume that n is more than equals to 30 is large, so that I can quote by central limit theorem. The distribution that we are looking for is x bar distribution. And x bar means you want to sum up this n different samples, we divide by n. So this will now be mu 36 over n approximately. We want to start with that statement or that probability that is given to us. I start from there, then I remind you what we can do to deal with this. Okay, let's recall what we have over the last lesson. How do you form a standard variable? Standard normal variable z is given by, you take the variable, you minus mean, and you divide by the standard deviation. So what we want to observe here is there is already a minus mu. Last lesson, we saw something like this. If you already have minus mu, you take one more step, you can get z by dividing both sides by SD. You want to divide the left and right hand side by standard deviation to form z. Now, why do I want to form z also? Is because there are a lot of unknowns. Mu is unknown, n is unknown. We only want to solve for one of them. I only want to solve for n. Okay, so common that you see minus mu, let's go and divide by standard deviation so that we can form z variable. Standard deviation is square root of your variance. So right hand side the same. We will simplify this number. Left hand side we get mod z. Right hand side I will get square root of n over 12. Let me simplify. And we have learned how to open up modulus. So can we open it up here? When we want to solve for this equation, there are certain things to note. What is your n? N is an integer unknown. When I see that I have an integer unknown that I want to find a range for, you will go for graphing calculator with table. Table is very, very commonly used in statistics, like you have seen over the last few chapters. Okay, so go for table, but the recommendation is you will shift everything to one side first. I want to move the 0.98 across to the left and set this to be a more than 0. Okay, so let's look at how to put it to the GC. I show you again. This is your usual step of putting in as a table. We are going to key probability, which is to key your normal CTF. Your lower and upper is now based on these two. Your n becomes the x. So I'm going to clear this. We are going to key the n as a x, and we divide by 12. Upper is the same. We have root x and divide by 12. Your mu SD is based on your current variable, which is z. So z is 0, 1. Okay, so lower upper is in terms of x because x is your unknown. So we paste it. I put it onto the graph, but I also key the negative 0.98. Okay, so I go to table. Table is located at second graph. But if I keep scrolling down, you will see that it's not getting very close to 0. What am I going to look for? I want to look for more than 0. Currently all negative. Let's recall how to jump. There are two ways to jump the numbers. You either press plus to change to, let's say, 100. Then it will jump by 100 on the left. Or you can go to second window for table setup. Second window, you can make the jump by any number you want. Okay, so let's start from maybe 500. We jump by 100. Let's look at the table again. You will find that the change is actually around 700 to 800. It's about there. So from that position, then you change back to 1. I don't want to jump by 100 now. I know the answer is about 800. I change back to a plus 1 at that position. And if I enter, I will go and locate the negative sign. Go and make sure you find the minus sign in front, not at the back. The E stands for times 10 to the power of. Okay, E stands for times 10 to the power of. So my answer is the change from 779 to 780, around that. Okay, let me put it onto the answer for you. For this, you have to show this table. Can we construct a table where I would like the table to have 3 rows and 2 columns, a small left column, looking something like this. When you fill in your table, left column will be your n. We were finding the n. Your right column will be this probability. We note down where the changes were located is 779 and 780. So at 779, you see that there's a negative. To be exact, you can actually move the cursor across to that position. Then you can see the more SF solution. Okay, so this is minus 2.49 times 10 power minus 5. Okay, so let's code that minus 2.49 times 10 to the power minus 5. And same for the next number, 5.46, 10 power minus 5. And importantly, what we were looking for is the change. This is negative, this is positive. We want the one that is positive, so I can now code that my least n will be 780. Okay, when do we use a table again? Table is for integer unknowns. Always move all to one side, not a must, but easier for you to find because you will locate the negative sign in front for your answer.